right, welcome to the fourth session for today, focusing on data in smart factories. And looking forward to insights from multiple perspectives from a couple of vendors on collecting and managing the data to leveraging the data to make smarter decisions in operation. Our moderator for this session is Hamish McKenzie with a background in analyst as well as a consulting. Welcome, Hamish, to the stage.
Thank you very much, Lucian. So good morning, good afternoon, or good evening, depending on where you are in the world. Thank you for joining us. My name is Hamish McKenzie, and this is the next IIoT World Manufacturing Day session, Edge to Cloud Synchronization, Seamless Data Flow for Smart Factories, sponsored today by Influx Data. First off, please do drop in the chat where you are, who you are, gives us a feel for who's joining us. While you do that, just a couple of bits of housekeeping. As I'm sure most of you know, it's an hour-long session. I'm going to introduce the topic and our speakers, and we'll obviously be getting a lot of insights from them. But we also want to try and leave some time at the end for the most important people in the room, which is you, our audience, to ask your questions. So with that in mind, please do get your questions into the Q&A function in the chat, Q&A function in the tool rather. Don't use the chat because it makes it harder for us to find them. And feel free to start getting them in there as soon as a question comes into your mind, then get it in there. Don't wait for the end. And that will make it more likely that we'll get your question answered. And even if we don't get to it live in the session, we will get back to you after the event with the answer to your question if we didn't manage to cover it live. All right, so with that said, let's focus on what we're going to be talking about. So we're going to be talking about how manufacturers can achieve seamless data synchronization between the edge devices and cloud platforms, and how that enables better insights, faster decision-making, and improved scalability. And we're also going to look at some of the challenges in terms of latency, data integration, security, and these kind of hybrid environments. And to help us go through all these difficult but really fascinating topics, we have two or three in fact, special guests. First of which is Ritwika Ghosh, who's Senior Product Manager at our sponsor today, Influx Data. Ritwika works on distributed Influx database solutions and data ecosystem integrations like Iceberg. She has more than 5 years of experience in product management and engineering. She is a former founding engineer at a Series A startup, and she has a PhD in computer science from the University of Illinois. So thank you very much for joining us today, Ritwika. Next up, we have Prasad Tarampur, who's manager at John Deere. He has over 20 years of digital manufacturing experience, automation, Industry 4.0, global experience in delivering smart factory programs for Fortune 500 firms. He has a master's in digital manufacturing and is PMP and AWS certified. And he really sees himself as an expert in aligning advanced technology with scalable manufacturing solutions. So great to have you here with us, Prasad. And next up, we have Pugal Janakiraman, who is Global Manufacturing CTO at Snowflake. He has over 20 years experience in transforming industrial sectors with digital tech. He's a former worldwide business development lead for industrial at AWS, and he also previously led the digital twin practice at Siemens. So he's got very deep experience in OEM across automotive, aerospace, heavy machinery, and he's very much focused on applying cloud and data innovations to various manufacturing use cases. So thank you for joining us again, Pugal. And finally, a few words about me, very much the least important person in the room, your moderator. My name is Hamish McKenzie. I'm a former IDC analyst, and I've been running my consulting business here in Germany since 2006. And I help small and mid-sized industrial tech with various aspects of their go-to-market, whether that be sales, marketing, recruitment. Of course, as AI is a big buzzword, has been now for the last 2 years, and I'm increasingly helping those small and medium-sized get to grips with how to implement AI in their organizations as well. If you want to know more about me, please look me up on LinkedIn. Shouldn't be too hard to find me. There's only one of me in Munich. So please do that, and make sure you get your questions into the Q&A function, as I said at the beginning. And with that, let's really get into it now. All right, so I like to start these sessions with a big context. And so I wanted to come to you first, Ritwika. Can you talk a little bit about how edge-to-cloud synchronization is starting to transform the manufacturing industry's approach to digital transformation beyond operational efficiency, which is kind of where most people usually start?
Yeah, great question to start with, and there's several aspects. So I'll start with one of the biggest headaches in manufacturing. That's data silos, right? That machine sensors and systems, they're all collecting data, but it's all stuck in its own little world. So edge to cloud synchronization basically smashes all these walls down, right? It allows data from all of these different sources to flow and be shared. And this also means, to use a term that data vendors like to use, democratizing data, right?
Mhm.
You're able to get the data in the hands of the experts that can actually use it. So it's not just your data engineers, it's your data scientists, mechanical and electrical engineers, business analysts, and decision makers. They're all getting a complete picture of what's happening across the entire operation and not just isolated snapshots. And that's what's needed, right? Decision makers need to get real time data, with edge computing, data that's generated on the factory floor and that can be processed locally on the edge. This allows for immediate action. If a machine is about to overheat, the system can react instantly by adjusting parameters or by sending an alert to the person who needs to react. And then for the big picture stuff, for long term analytics, identifying trends, that data needs to be sent to the cloud. And I think that's a way to also modernize legacy systems. You don't just have to throw your old equipment away, or be stuck using deprecated software. You can basically plug your old equipment into this new digital ecosystem. Basically, you can enter a smart factory era without a complete overhaul. And to add a little bit of perspective from our own experiences, that was a big driver towards InfluxDB3. We really wanted this connectivity, the push for edge data replication, where you're able to connect edge and cloud workloads to automatically mirror data from, say, the edge sources to cloud instances in real time. And so we really invested in the Air Rust ecosystem, the Parquet file format, and the data fusion to be able to provide this connectivity and leverage the potential of using this edge to cloud synchronization. Because you need the massive processing power and the cost effective storage that cloud providers can bring to you. And once that data is in the cloud, you can start using historical and real time data for things like predictive maintenance. You can use machine learning and AI to predict when something is likely to fail before it happens. And this leads to a much smarter, data driven, and strategic decision making process for the entire business. So, yeah, I
Fantastic.
think it's very transformative.
And I'm glad that you mentioned that word strategy. Now we're going to come back and get into the weeds on the technical side in a minute. But I was just focusing on that strategic aspect for a minute. I wanted to come to Pugal, who I know has some thoughts about the role that executive leadership should play in driving some of these successful edge to cloud synchronization strategies across the organization. Because without that kind of, not just buy-in, but also momentum coming from the leadership, that's sometimes where some of these projects fail to deliver the value that's expected. So Pugal, could you just talk about that leadership aspect a little bit?
Yeah, definitely, Hamish. I think that's an important aspect for any of a successful implementation. We need that executive leadership from the customer side and even from the vendor side implementing it on setting the North Star vision for that whole initiative from a company goal point of view. What is that company trying to accomplish? What is digital transformation? Added to that, what are those top one or two or three use cases you are trying to execute on top of this edge to cloud transformation journey? Because you're not just moving the data from edge to the cloud for just because cheaper to move the data and then store it in the cloud or use the compute horsepower. Manufacturing or a production operation does not care. End of the day, they're looking at with this, can I produce more? Can I produce more with less? Can I produce better quality? Those are all the use cases. That is what is driving them. For this project to stand on its own legs, after the initial pilot and prototype, that use case and outcome is super important. That's what we discuss with the customers. The day one we walk into their offices. Hey, this is all good. We can provide you with amazing solutions to on this digital transformation journey. And what do you do it at the edge? As Ritvika mentioned, right? It's like you cannot accomplish this digital transformation just with cloud alone or edge alone. It's a combination of both, a hybrid architecture. But for that journey to begin, what to do, where, and where do you store the data and for how long, all those critical questions needs to be answered. The use case matters, and the leadership from the customer matters on that to set that North Star vision, make sure that all the stakeholders are bought in. Super important for this initiative to be successful. I would say that's where we should get this going.
Yeah, no, absolutely. All right, so let's have a look at some implementation challenges then. So Prasad, if I could come to you, what are some of the biggest technical hurdles the manufacturers face when they're implementing data synchronization between edge devices and cloud platforms in a production environment?
Yeah, sure. Thanks, Amish. To put these things in perspective, would like to start from where we started and where we have reached, starting
Mhm.
from industry 1.0 to 4.0. If you recall, this whole journey, the most popular industry 1.0, 2.0, 3.0, and 4.0 transformation. So 1.0 was all about very very early days of machines, and then 2.0 electricity, 3.0 basic automation, and 4.0 is the current era that we call as a current cyber digital cyber system. So as far, and that's where the birth of data, the explosion of data has been taking place since last few years, because in earlier industry 1.0, 2.0, initially there was no data, and then gradually the data started building, starting from analog form and then moving towards the digital one. When it, and if you see, like many years before, I got a chance to visit some of the very big companies, and I saw that early in 2000 and 2000 and 2005, that there are still machines from Second World War. Can you imagine? In that are still running in the factory. And yes,
Yeah.
that one of the factory was from Germany, by the way. I was in Germany. And US as well. Yeah, so there are some machines from the Second World War, and they're still running, and they're mechanically absolutely rugged and highly performing machine. And the production manager or the plant owner says that no, I want to keep the machine running as it is, and get me the data, run the digital transformation on this factory. So the typical challenge, that we start with, first of all, the proprietary and age-old protocols, right from serial protocol, then Modbus, analog. I mean, uh, I have seen some of the machines, when I was in Germany. In fact, it was completely the relay-based machine, relay-based and analog input-output machine, and it was really difficult to extract any data from that machine. So these are the real challenges. In fact, still in the world, there are many companies, who have been running with the similar kind of machine, and absolutely it does not make any economic sense just to change the machine just for the sake of digital transformation. And that's where the technical experts and consultant in the industry, just like us, we come together and find out the solution. So challenges point of view, first I talked about the proprietary protocols. The
Mhm.
second is data volume and bandwidth. What has happened that after 2010, especially in India, there has been an explosion of data as far as the factory shop floor is concerned. Because earlier this IT and OT was never connected for many years, and it just after emergence of Industry 4.0, this the actual connectivity started taking place. So thousands of sensors are sending data per second to the from OT to the IT. So handling this massive data is is a prime concern, and one of the prime challenge as far as the IoT gateway and edge gateways are concerned. The third challenge that comes to my mind is definitely security, right? OT security. We have been hearing the news from last 2 decades that this OT related cyber attack has been one of the pressing concern for all the manufacturer, because IT security has been taken care many decades before, but OT security, but because for the cyber attackers, that's the sweet spot right now. So introducing any edge device in the shop floor environment has to be done very responsibly. There has to be many checks. So that's the third challenge: security and the data privacy. And the last challenge that I could see is the real time. Let me give an analogy. If you are working on machine and there is an operator, if you hit the emergency stop because of some reasons, the machine has to stop immediately, with not in seconds, but in milliseconds, in fact microseconds. We
Mhm.
cannot afford any latency, we cannot afford any delay in that. That's the fourth challenge that I see, that introducing edge gateway has to be done very carefully by taking care of the latency related aspect. So these are the 4 to 5 challenges, that we see, and that is typically due to, every industry has been transforming, at a different level, which we talked about 1.0 to 4.0. Yes, Hamish.
Fantastic. Okay, thank you very much for that, Prasad. And you mentioned there increasing data volumes, which is obviously that's not going away anytime soon. And I wanted to ask Pugal, as manufacturing systems are generating just more and more and more and more data, how can organizations design synchronization architectures that are scalable, but which also remain cost effective as the volume of data, just keeps getting bigger?
Yeah, definitely. I think we deal with this on a daily basis on and
Mm.
engagements, Hamish. So the first one is, I think I want to just start with the basics, right? You don't need to send every possible data point or tags which is coming out of manufacturing facility to a cloud infrastructure. It's a function of a use case. You only send subset of it. That is the first and foremost rule. The other one is the very important thing to look at as well is, I think it's going with the fundamental principles with which we have to architect is, it is edge driven, because the knowledge of the business and the use case resides in the plant floor, not in the cloud infrastructure, not with the data scientist. So
Mhm.
we have to work with the right set of people in context of use case to get only what the data is relevant into a cloud infrastructure. I think that's one. That's going to bring down drastically the volume of data. The other one is, how do you handle the velocity of the data as well? Because this data is getting generated in milliseconds, microseconds, nanoseconds, depending on what production processes and machines we are looking at. So that's why we go with a more modern, published by exception, MQTT based approach to send the data to the cloud. There are a lot of approaches in which, as I think Prasad mentioned, manufacturing environment, there are 350 plus protocols with which assets talk to each other. Modbus, I think, was something we discussed as well. Modbus was invented 40 years back. It is going to be there another 40 years. We have to deal with it. But we are not going to use this inefficient polling algorithms to ask from the cloud what is changing at the edge. Instead of that, use MQTT, which is published by exception. After that, you can easily handle the velocity, because 90% of the time, data on a machine does not change when it's operating in a steady state mode. It's only 10% of the time it changes. So with that scenario, you don't bring the network down with sending every possible data point to the cloud, whether it is changing or not changing. You only send it when it changes. So that's going to bring down 90% of the payload down at a manufacturing environment, and it's published by exception, and it's MQTT based, extremely efficient way to send the data into a cloud infrastructure. So I would say those are the most modern approach, proven well today. The current day technology, that's the best way to do this.
Okay, fantastic. Thank you, Prasad. And so just coming back to you, Prasad, in terms of data retention, so how should manufacturers approach data retention differently, depending on when we're talking about data at the edge versus cloud data in warehouses, particularly when we're talking about in the context of performance and cost?
Correct.
What are some of the differences that manufacturers need to bear in mind?
Correct. Exactly. Again, to put things in the perspective, which data to keep on the edge and which one on the cloud. Right now there is no, I would say, a standard guideline. Okay, but definitely we have to use some of the matrices, some of the I would say key indicators to determine which data has to reside on edge and which data needs to go on the cloud, because the industry is also learning by doing. So to my experience, what we have seen, as far as the age is concerned, generally speaking, the short duration data, let's say you're processing some you have some application running on the shop floor and you want to use that data for the very short time, let's say for minutes to few days, that something can definitely reside on the edge. Also, another is sometime we can also consider the rolling buffer, where we can automatically delete the data after certain threshold. It could be 1 day, 3 day, because inherently edge devices has limited computing capacity and limited storage capacity as well. So definitely, because if we continue to store the data locally, it is going to overload the edge computes, and obviously that's not the purpose of the edge computing. So, to short answer for the edge is using the storing the data for the short amount of time for the as far as the edge gateways are concerned, and as far as the cloud is concerned, wherever we want to store the long-term data. For example, historical analysis, the reports that you may want to generate in future, or the one database to another database, comparison types of report. Those kind of long-term analysis report can be certainly stored on the cloud, so that there is a clear uh, isolation, or there is a clear way to store the data uh, as per the purpose. Also sometime policies also may dictate. For example, if you go to the pharma industry, definitely they may want to store the data on the cloud for longer duration of time. So we popularly in the cloud computing world called as a hot storage, warm storage, and cold storage. So generally cold storage is also called for low access, and generally for the long term. Warm is something for the medium term, and hot is something very recent and for quick access. So these are some of the strategies that we can keep in mind, so that we can use edge computing effectively.
Okay, fantastic. All right, so we've talked a bit about challenges. Just in the interest of completeness, is there anything from all of yours perspectives when it comes to the challenges of this synchronization aspect? Is there anything that we haven't covered that you want to? Anything else you want to mention?
Yeah, I think maybe I would like to add a bunch of challenges on that front, Hamish,
Mm-hmm.
in addition to what I think Ritvika and Prasad talked about. Um, the biggest challenge which happens, which I have noticed time and again, is trivializing the OT side of the world. And what will it take to connect to those OT assets,
Yeah.
gather the right data set, and in a scalable way get into a cloud infrastructure and define that edge to cloud compute model, hybrid architecture. It's not a trivial activity. That's one. And a lot of these projects get slowed down and fail when people trivialize that, or they think that it is no different from an IT integration. They try to build it on their own. There is no point in doing that. In fact, pretty much in most of the cloud vendors have figured this out on how to do that efficiently. We have done this pretty efficiently. I did this in my earlier role in AWS. Now I did the same thing in Snowflake.
Mm-hmm.
Pretty much we can connect to any manufacturing assets, whether it is invented now or obviously with the Second World War era machine, which I come across all the time as well, Prasad, in aerospace industry. It functions well. Nobody wants to touch it. I wouldn't ask them to change it. We can always add some additional sensors to that, but independent of that, most of the machines invented are the PLC SCADA system from the last 40 years. We should be able to pull the data out as long as there is no legal contract stopping that customers from. It happens as well. So we have streamlined that hugely. So again, the goal is we have taken that problem away from you. Please focus on solving your business outcomes. That is the value to your customers. There is no value in you trying to solve this problem. We have done that pretty efficiently. I think that's what I would love to add to that. Maybe one other thing, if you don't mind, I would like to add to your earlier question as well, Hamish. where you talked about this data synchronization and the edge, why do you store data and all of it. What we have seen working with customers on this on a daily basis, I would break down the decision-making process on how much you store and how long. It is related to the system architecture. For example, if you are using MQTT, if the network goes down, you still have to buffer it at the edge. So whenever the network comes back up, it should be able to publish. Minimally, that system has to do that. The other one is the cost reasons. And cost point of view, long-term storage, possibly hugely cheaper to do that in cloud. And also the elasticity involved there, we can keep storing it. That is another thing between edge versus cloud. Obviously, the third one we have to look at is also the legal compliance requirements. If I go into pharma, if I go into, for example, aerospace industry, I cannot even send certain tags into a cloud infrastructure. They will never take it to cloud. They will always store it at the edge and do the compute for legal reasons. Obviously, fourth aspect of it we have to look into it is the business use case point of view. So what is that near real-time analytics? You want to do it at the edge, which makes no sense to do it in the cloud. L1 to L3 analytics, I would always tell customers, don't do it in the cloud. I'm from a cloud company. It makes no sense to do that. Do it at the edge. And what does that L1 to L3 means is something we have to define at the customer side, near real-time requirements. And for that, store that few hours to 1 day to few days worth of data at the edge. Rest of it goes to the cloud. That's the right way to do that. There is no one way to do that. We have to look at all these dimensions to solve this problem.
Yeah, fantastic. And I think that's a very important point and refreshing to just be honest and say, listen, cloud is not the answer every time. And sometimes you have to, I've had experiences where people are just pushing for the cloud even when it doesn't necessarily make sense. So I think that's a really important point. All right, so we've talked a lot about challenges. So in the interest of staying positive, let's move on to talk about some solutions now, and to get a bit more into the weeds about all this. So Ridwika, I wanted to ask you, in terms of how can manufacturers effectively integrate time series databases, for example, at the edge, with cloud-based data warehouses, and thereby creating a kind of cohesive, complete data architecture that supports the real-time aspect that Prasad was also talking about, but also historical analysis as well. So yeah, just talk around that a little bit, please.
Yeah, sure. And actually, I'm very happy that Pogal actually addressed the approach towards doing that, because that kind of has a good segue into my thought towards it. So time series databases are built to handle that massive stream of data and get those immediate monitoring and local insights. And cloud-based warehouses are designed for that long-term storage, complex analytics, and enterprise-wide reporting, right? And as you guys have been saying, the idea is to send that valuable time series data from the edge up to the cloud to be consolidated with business data, like information from your ERP system, supply chain data, quality control records, to ask those bigger questions and get the deeper insights. And I've seen several common integration patterns like ETL, extract, transform, load, ELT, maybe using an intermediate data lake to store things, or streaming ingestion tools like Kafka. And these are valid approaches, and I've seen data engineers pull some truly miraculous and heroic things using them by building and maintaining these custom integrations. But that can get very expensive and very quickly. So in terms of how to effectively do this, data vendors are starting to talk a lot about efficient and targeted connectors. So if you can find pre-built, optimized connectors between your specific edge database and your cloud data warehouse, it's going to prevent a lot of pain and save a ton of money. And just connecting those pipes isn't enough, though, right? So for the integration to be truly effective, you need some other things. And starting with data governance: who owns the data? Who can access this? How is it secured? All of these new rules need to be clear. Then you have data quality measures. You need processes to ensure that the data that's coming from the edge is accurate and reliable and in a format that the cloud can consume. So from the engineering perspective, you need a common language for your data, for the edge and the cloud systems to understand each other perfectly. Small things like how variants are handled across systems. I get a look from the data engineers every time I say variant. Little things like making sure reading is always flow 32 and not sometimes a string. Um, Things like this can make a huge difference. And optimized query performance for both the real-time and edge use cases and the analytics use cases. These are different needs, and your architecture needs to be able to support both of these needs efficiently. And I think there's been a shift in the thinking over the last few years, specifically the unified one-stop shop approach where you try to get everything from one vendor is kind of last generation. Companies are increasingly embracing open data protocols and open table formats like Iceberg or Delta Lake. And this allows users to pick the best tool for each part of their data ecosystem. So you choose the best in breed for time series databases at the edge and best in breed for cloud warehouse for the cloud, and leverage the open standards to make them work together. So yeah.
Okay, fantastic. Thank you for that, Ritwika. All right, I want to come on now to, I mean, so let's say we've got the architecture in place, okay? We've done everything you've just suggested, all fantastic. However, if you can't turn data into actionable insight, then you have a problem. So, Pugal, I wanted to ask you, what do you see as the most effective ways of doing that from a visualization and analytics perspective, so that we can get all this synchronized data transformed into really, insights that the different stakeholder groups within an organization can use for their own, for their own ends, for their own goals. What's the most effective that you've seen in the field?
Yeah, I think again that's a pretty important question which we have to think through and answer as well. And in fact, that is a huge focus area for us today from Snowflake side as well. Hamish. So there are a lot of foundational requirements which we have to satisfy, and there is also a historical background from the manufacturing customers, how they look at data, how they have traditionally analyzed data. We should be able to handle it. The first thing is this is pretty large volume of data, and let's assume that we have solved this problem of IT and OT convergence. We are able to bring it together, construct one unified namespace, bring the data in. We are doing that today with a whole bunch of customers. The first question which comes from customers is, we are looking at hundreds of thousands of data points, millions and millions of records. My company for the last 30 years is using Excel spreadsheets to analyze the data. Can you provide a mechanism with which we can slice and dice the data without being a paradigm shift, but in scale? We should be able to visualize this data, navigate the namespace, set up condition monitoring and alerts when things are changing, go do that. This cannot be a humongous multi-year project implementation. This should be available out of the box from any cloud vendor like us to satisfy that kind of needs. Because at the end of the day, we have a data warehousing infrastructure in the back end and a data platform, AI platform, all of it built into one service from our side. If I cannot visualize the data, we have a problem. And we cannot support the traditional methodology in which they have done that, which is Excel, that mindset, the paradigm and all of it. We want to support that. So we have to provide a codeless way to, the minute the data lands, this IT and OT, and then UNS is constructed in a cloud infrastructure, you should be able to navigate that unified namespace from a plant hierarchy, assets, lines, machines, unit of measure. Along with that, also virtual add-on kind of requirements configured on top of it, where notify me if the machine is down, or the machine is underperforming, or it is going to be down a couple of hours from now, or my quality is trending down, my OE insights, I want to break it down by performance availability. It is all possible today, very much possible today, by bringing in a bunch of things. One is a scalable way to visualize this data formats without a code involved here. That's the first crucial requirement, because we cannot ask them to do it. The next one is, how can they consume now the LLMs, AI and ML without being a data scientist. It is possible today. That is the beauty of LLM. It has democratizes the technology because we have democratized the data with all this amazing connectivity for IT and OT into a cloud infrastructure. Now you don't need to be a data scientist. You don't need to write SQL code. You don't need to write a Python code. Now with an LLM, I can ask a question. Hey, I'm seeing an OE downtime or some other issue happening on a plant floor. Can you tell me what those root cause could be? We can easily do a prompt engineering and then come up with a certain scenarios where the system can do that work for you. And also the graphs and the charts, SQL queries in the backend, we completely generate using LLMs. We don't expect the user to know these are the 30 tables I need to bring together. The SQL has to be constructed. We are providing that out of the box capability to accomplish that. Whether you do it within native to Snowflake environment or you want to do it in a third party tool, we support both of it because the real world customers use all of it. So, and to close that train of thought as well, Hamish, the final thing is the agents today. These are force multipliers today. You can do more with less. I think somebody put it out as a point that this is super important. Cannot agree more on that statement because that's what the customers want to do. They want to do more with less, whether it is money or the labor. At the end of the day, it all comes down to money. That's what the customers are trying to do. Now the agents are now available to be those configurable workers, maybe once a shift, once an hour. The agents can wake up and look at the work orders and what you have produced so far, and it can do a prediction that, hey, you know what, you can hit the number or you might not hit the number. Today production metrics, and if you cannot hit the number immediately, you can also ask a question: is there an excess capacity somewhere else so I can shift the production, or is my line going to starve? These are all the foundational questions. You can let agents to do it ahead of time, interact with each other to raise a work order if you think there is one thing going to be down or the spare part is not available. A lot of these things can be accomplished today in a much more easy fashion compared to where we were even like 10 years back or 14 years back when I started this Industry 4.0 journey. It's a painful way to do that. Now, these technology tools are available. Again, I'm not saying you have to completely trust the technology to AI to go set the machine operation differently, shut it down, and all of it. Most probably, there is going to be a human in the middle, but that human in the middle be really efficient to give them the right tools to do it because they know manufacturing, they know production. They're asking for better tools. We can do that today. So I think that's my long answer to that question, Hamish.
No, fantastic, fantastic. You're absolutely right, and the rate of change or the rate of improvement is only gonna accelerate, at least for the time being. And as I keep hearing, or keep getting reminded, all these, especially on the AI front, what they're like today is the worst they're ever going to be, and they're already incredibly powerful. So we're only going in one direction.
Yeah. Maybe can I add, Hamish?
Yeah, of course. Yeah.
Yeah. So definitely, Pugal, thanks for bringing all these definitely very important point. There is a famous saying that what you cannot see, you cannot measure, and what you cannot measure, you cannot improve. The IT industry understood this 2 decades back, right? And now slowly the manufacturing companies have realized the importance of not only collecting the data and measuring. And definitely there are still we call as OEM, tier 1 supplier, tier 2 supplier. There are many organizations who have just started this journey, right? So that's first thing. Many times manufacturer thinks that do I really need to capture the data? Hypothetical analysis. But definitely, what I have learned from the experience that yes, collecting the data is very important. Yes, there will be sometimes, let's say you captured thousands of data points. Not necessary that all thousands of data points has to lead to some kind of analysis or result. That's okay. There will be some data which will be of no use. That's fine. But out of those thousands of points, there will be 100 data points maybe which will transform your manufacturing line like anything, and will give you 2x or 3x or 10x return. So to reach to that 100 data points, it's required to collect those hundred thousands of data points. So that's one. That's where the edge computing comes into the picture, because of the legacy system, because of the legacy and proprietary protocol, which we are not able to collect the data. That's where the edge computing comes into the picture, where we can collect the data and process at the edge. So that was my 2 cents to add what Google said. Yes, Amish. Amish, can you hear me?
I think
Sorry.
you're
Sorry about that. Thank you.
Yeah.
So thank you for that very valuable point. Another important aspect of this, and I'm hearing this or experiencing it also in all sorts of. I work with lots of different companies across all different sectors, and one of the most important aspects of, I think, successful implementation is partnership. Between all the players involved in getting the synchronization right for the customer. So Ridwika, I wanted to ask you when companies are looking for technology partners to take them or to ride with them on this kind of edge to cloud synchronization journey, what are the key considerations? What should they be looking for when they're choosing those partners?
So I think we can all agree that finding the right technology partners is not about the shiniest new toy, right? It's about finding partners who will set you up for long-term success. Obviously, one of the main consideration is openness and interoperability. Your edge solutions and your cloud platform need to be able to communicate effectively with all of your interfaces and with each other using open standards and protocols. And this is important for future-proofing your setup. You don't want to hit a roadblock later because your chosen partners cannot evolve with your evolving tech. And speaking of evolving tech, there's also evolving data, like both of you have mentioned before. The amount of data you're collecting today might seem like a lot, but as you add more sensors, more machines, more factories, and more analytics, the volume is going to explode. So you need systems that grow with you and don't hold you back, and without the costs growing up exponentially. And this cost is not just infrastructure costs, it is human cost as well. It's not just your top data engineers who are going to be talking to that data. Engineers, ID staff, maybe even operators on the floor might need to use these tools or interpret the data. There are two aspects. One is good user experience and product design, and the other is great technical documentation and responsive support. So that's very important that you choose a partner who has good support. And of course, cost effectiveness and flexible deployment are always key. You need to look beyond just what is the initial price tag and consider the total cost of ownership, right? What are the ongoing subscription fees? What are the infrastructure requirements? Are there hidden costs? How flexible are the deployment options? We have a lot of customers, for instance, who want to deploy an air-gapped on-premise environment. So deploy on-premise, in the cloud, hybrid models, you should choose partners who are able to meet your deployment needs and within your budget. And finally, I think it's important to look for partners with a strong community and a vibrant partner ecosystem.
Okay.
Strong community means more shared knowledge and more solutions to common problems and a ton of third-party expertise that you can tap into. And a good partner ecosystem comes with pre-built integrations and specialized services. And being part of a company that was built on open source products, I keep being pleasantly surprised by how effective the community is finding solutions to problems that our engineers may not have thought of. So yeah, I think these are the considerations that I would bring to choosing a partner to grow with.
Yeah, I think that aspect of community is super, super important. I know it is to me in every aspect of what I do, and for my customers as well. They're always leveraging the value of their networks, their partnerships, their communities in order to, as you say, find solutions that maybe their own people didn't even It hadn't even crossed their mind yet. So incredibly powerful. Okay. Any Prasad, Pugal, is there anything you want to mention on the partnership front before we move on?
Yeah, I think if I have to add some more points to that, Amish, manufacturing, it's an ecosystem play. There's
Yeah.
no one single vendor who's going to solve all the problems. It's impossible to do it. The number is always greater than one, whether it's a fact, and whether the customer wants it or not. The reality is that, pretty much, right? That's what we keep in mind to solve the manufacturing problem. More so for us, right? It's like we are a cloud company. We don't do anything on the edge, but it's end of the day, manufacturing is a hybrid architecture. We had to partner with the best in class players out there to build that ecosystem for a hardware vendor, edge databases. That's why we are on this call together. Along with that, we are also working with edge connectivity players, because protocol conversion, MQTT conversion, things like that. Every aspect of it happens through best of the best, working with the partner ecosystem. That's how you build the whole thing. That's what we have done, and that's pretty much the only way to do this. So finally, when you present an architecture to a customer, it might involve more than one solution, but it is a best-in-class solution which can scale to any of their needs. That's the work before us. Again, there is no one single answer to that or one magic architecture. This is something we have to understand also the incumbency within the plant floor. If they are using a certain type of, for example, if they're using Kepware for connectivity, we have to work with that Kepware to go connect. They're using Ignition, much better portfolio. I can easily do a lot more things and seamless way to do the same thing. Our answer is, it is an ecosystem play, and it's a brownfield environment what we are walking into at plant floor. There is a 40-year plus legacy involved here. There is no way the plant is going to change because we got this fancy thing called as cloud and AI, and magically I can do a lot of things which has not been possible. I have to take into account what is at the plant floor and build a solution which is going to involve not a lot of changes to the customer, because production, they are going to run the same production, whatever you like it or not. Machines are not changed. We have to deal with that and build that solution architecture. Only way to do that is with ecosystem, the right ecosystem.
Yeah, no, absolutely. Great point,
Yeah.
Prasad. Thank you. Yeah, Prasad, do you want to add something or?
Yeah, just one point with what
Yeah.
Google said. Definitely, choosing the right vendor, who can support to the open standards, right? Be it OPC, UA, MQTT, and avoid any kind of vendor lock-in, because that has been sometime an issue. In fact, there has been many incidences in manufacturing. I have seen in my 2 decades of journey. I mean, the sometime the person who sold the edge hardware, sometime they have gone out of business, and the manufacturer, have been stuck, right? Because the world is changing fast. Like we have a Azure IoT now, AWS IoT, MQTT. These modern protocols are coming. Modern H2 cloud connectivity protocols are coming in the market. So definitely we would one would need to check that the vendor capability in terms of their thought process, how they are evolving themselves with the changing environment. For example, AI. There has been a lot discussion around AI at the edge. I mean, if you don't use the word AI in today's con call, maybe that will be a big issue in today's context. Everywhere there has been a talk of AI. So AI at the edge, that has been the new word. Definitely, some capabilities are still need to be validated. ROI still needs to be verified, but definitely the vendor is expected to take care of this. That how the upcoming and emerging solutions are going to be part of their offerings.
Okay, fantastic. Thank you. All right, so I want to get to some questions, audience questions in a minute. Before we do that, I want to ask you each to get your crystal ball out, respective crystal ball, and give me one trend which you think is going to emerge in the next 3 to 5 years. Maybe it's already visible, maybe not, in this edge of the cloud synchronization context. So, Ridwika, start with you. What's the trend that you would pick out?
I'm gonna pick the easiest one to see, which is AI-driven edge computing. We're gonna see more AI, not just in the crowd, but at the edge for more real-time decisions using synchronized feedback loops, where insights from the edge can immediately influence those decisions and feed more intelligent data back to the cloud for long-term analytics.
Okay, fantastic. Thank you. Pugal?
I can think of a bunch of things on this front, Hamish. I think I will 1000% agree with what Ritvika mentioned. Edge is getting more and more powerful. More and more GPUs and all of it is available at a much, much lower cost now. So lot more related work and analytics and all those things are going to happen at the edge. That's a reality, whatever it is. That's going to happen. The other one I can definitely see, this is, even though it is out of the possible, it's early in the hype cycle and all of it, but the potential is huge, is the agents, orchestration of agents, setting up some business infrastructure, rule infrastructure to coordinate agents, because it's a no-brainer. When manufacturing is trying to do more with less, you need a force multiplier like agents, which is going to at least prep the data, get insights to the data, get some predictions to the humans in the middle. So they get more and more, they are better equipped with the latest tools, because these are really smart individuals who are running production, really intelligent people who learned how to do that in a very efficient way in a pretty aggressive environment, because production environment, that's how it is. Giving them this better tools, it's a no-brainer. We can see that already, the trend happening. The art of possible is huge in that area. So edge, agents, AI adoption, these are all, it's pretty clear so far. And we can see the trend already happening, data points coming in.
All right, fantastic. Thank you, Pugal. Prasad, anything to add?
Yeah, very, very valid points, Pugul and Ritvika. Uh, the new trends point of view, two things comes into my mind. The OT security, because definitely, all the edge device manufacturer as a, and then as a vendor, and the companies, who are intent to buy. So definitely the security question will be the key. So there has been a lot of talk about zero trust architecture. So this trend will pick up from now. I mean, this has been already kind of becoming mainstream, that how the edge devices that comes into the shop floor is already inbuilt with all the compliant OT cybersecurity. And the second is definitely, this decision making at the edge, or which Ritika and Pugal said, like AI at the edge, or in other words, machine learning at the edge. Earlier, all these machine learning modules which consumes the heavy compute used to be kept at some common another server, and then edge used to send the raw data to some kind of centralized server and get the decision from that server. So now, with as Pugal mentioned, these GPUs are coming into the market. So definitely, in coming days, definitely there will be no need to run the model on the central server, and it can run on the same edge gateway at the shop floor at the edge. So it will eventually help for the real-time decision making.
Okay, fantastic. Thank you very much, Prasad. All right, we've got a few minutes left over now for some audience questions. So I'm just going to come to one from Chris Daly first, because it speaks to what Pugal was just talking about, I think. So he asks, have we seen many real use cases which are based on this, orchestrating agents, agentic AI, synchronizing across domains, in a real-time edge setting in particular, or are we still just experimenting, or is this already happening now?
Yeah, I can take a first shot at it, Hamish. I think because recently, based on the continuous customer ask, we launched in fact, this is a capability we just launched, and even before, I would say, officially getting into a huge launch process, a lot of customers were interested in that area. One consistent ask which comes from them is, how do I know if I'm going to meet my production targets for the day? Because you got a work orders coming in the morning, that work, how much you are going to produce for month out, 6 months out, these are all decided before. model mix and stuff like that. And if you got a production orders based on the current trends, can you let me know? Can agents continuously analyze and send me an alert that if there is something to be concerned about? Or understanding the transportation logistics for inbound to know in just-in-time production, if you're only maintaining 2 hours worth of inventory, if the inbound is going to be delayed, is there an alternate source I need to be looking at? So alert the people ahead of time, things like that. Or there is a major issue happening in some, I don't know, Panama Canal, there is an issue happening, or there is some famine happening, or some issue, geopolitical issue going on. How is that going to impact my supply chain? Continuously agents to monitor that. These are all the consistent asks coming in. Production side of it, we already built a solution and launched it where you can configure by shift level, by hourly basis, or every half a day. Agents can wake up and let you know the health of production and if there are any concerning things to look at. This we already built it, and customers are already in the process of adopting it. Even though I would say it's early in the hype cycle, there is huge interest and there is huge potentials with thought leaders trying to ask these things from us. So that's where we are.
Fantastic. All right, thank you for that, Bhagat. Question specifically for Prasad, I saw here. How is John Deere leveraging data all the way from the machines, which is, as he says, a very far away edge, back into the factories? How is John Deere managing that whole that process?
Okay. In the interest of confidentiality, I may not be able to share the direct information, but
Yeah.
in general, I will still address that, based on
Yeah.
my experience with the another Fortune 500 organizations which I've worked in the recent past. Definitely, I will give the typical example, the Second World War machines in Germany, the factory which I visited. So we had almost 500 machines, okay, no PLC, no protocol. In fact, there was no even any digital input output. It was all analog, and we were tasked, to bring the data to the edge, so that and then for the analysis purpose. So there we use this, edge computing. We use the special edge devices, which collected the data from the machine by using the digital input and output card, because we had to do some specialized wiring to that machine, use the special sensors to bring the data from the machines, and then aggregate data at not one but multiple edge devices as per the process. So let's say early production process, then finishing process, and then aggregate to the central computing level. So that's one of the area. That's how the edge computing can be leveraged. The companies who already have modern infrastructure, but still, as Google mentioned in one of the example, what if my network is down, right? And you have some critical data. Let's take an example of pharma, where we cannot afford to lose the data. And if we lose the connection with the centralized network, and if you lose the data, that's not going to be acceptable. So that's where one of the concept called the store and forward, so that your local edge device can store the data until your centralized upstream is down, and once the upstream is up, it can send the data to the upstream. So these are some of the ways that can be managed.
Fantastic. All right, thanks for that very real-world example, Prasad. That's great. All right, unfortunately, we've run out of time. Everybody who's asked a question who didn't get an answer to it live in the session, we will get back to you after the event to give you an answer to your question. So don't worry, you will get an answer. But unfortunately, we just ran out of time. There's always so much to say about all these topics. All right, so it just remains for me to say thank you very much to our great panelists for all your insights, knowledge. Thank you very much to Influx Data for sponsoring the session. Without you, we wouldn't be able to run these events, so we're very appreciative of that as well, of course. And thanks also to everyone who's attended the session. If you're staying around for the rest of the event, I'm hosting one more session on AI in an hour or so's time. So if you're coming to that, I'll see you there. Otherwise, please move on now to the next session, which is the Connected Factory, Driving Real-Time Insights with OT Data in the Unified Namespace, sponsored by Cirrus Link and HiByte. All right, thank you very much. Have a great rest of your day.